Hello everyone, we're Team Supramolecular Pandas from Universidad de las Américas Puebla. We're going to present a chemical sensor. Our content is synthesis, characterization, applications, and references.
Dioxide doped with antimony oxide can be carried out by two methods: by precipitation. 0.3 molar aqueous solution of tin sulfate and 0.1 molar of antimony acetate were prepared separately, with the addition of nitric acid until a value of pH 8.3 was reached. After that, it was aged for 24 hours and filtered under vacuum and then left to dry in an oven at 60 degrees Celsius for 12 hours. Using the polymeric precursor method, 59.11 milliliters of ethylene glycol were first heated and 52.54 grams were added of citric acid and stirred until a clear solution was obtained. Separately, a 0.1 molar aqueous solution of antimony acetate was prepared by adding nitric acid. Tin sulfate and antimony precursor solution were added to the ethylene glycol and citric acid solution. Both precursors are mixed and brought to a pH of 9 with ammonium hydroxide heated to 120 degrees Celsius and finally calcinated at 350 Celsius degrees.
Characterization of the ceramic powders, carried out by the two methods, was made via thermal analysis in a dry air atmosphere. With this technique, the temperatures where phase changes occurred, phases of organic decomposition and crystallization processes were determined. The results show the particles clustering up for both samples. A suggestion to correct this was to add a grind stage or a surfactant such as oleic acid with the purpose of generating a steric effect and thus separating the particles. FTIR spectroscopy was also used to determine the functional groups present in the system. Furthermore, the size distribution of the polar particles was measured using a scanning electron microscopy. For the identification of the main crystalline phases, X-ray diffraction was employed for both samples, which showed a significant difference in their morphology because one had been heat-treated before. Finally, the electric characterization of the sensor was done by registering the variation in the resistance of each sample under different atmospheres, such as oxygen and carbon monoxide.
Gas sensors are devices capable of detecting the presence of a particular gas. Sometimes, the gas sensor can be configured to be even more accurate in order to measure the concentration of the gas. Sometimes, the gas sensor can be configured to be even more accurate in order to measure the concentration of the gas. Gas sensors are commonly used to avoid exposure to combustible gases. These types of sensors are very useful since they can operate in a wide range of humid environments. For all above mentioned reasons, gas sensors are very useful in daily life and to solve certain conflict situations.